In the great architecture of the cosmos, every structure, every star, every atom exists within a delicate equilibrium of forces. Gravity holds planets in motion. Radiation presses outward from stellar cores. And the universe expands with a steady, almost meditative rhythm. Yet buried within this orderly framework are anomalies. Regions where nature's rules buckle under pressures so immense that even the laws thought to govern the fabric of reality falter. Among the most enigmatic of these anomalies is the black hole. A black hole is not merely a dark sphere suspended in the void. It is a condition of spacetime itself. It is gravity elevated to its absolute extreme. A concentration of mass so dense that the surrounding space curves inward with relentless, irresistible force. From afar, its presence is visible only through distortion. The bending of starlight, the warping of cosmic structures, the violent radiation emitted by matter spiraling toward its boundary. At its center lies a singularity. A mathematical point where density becomes infinite and classical physics ceases to apply. The existence of such an entity begins with the end of a massive star. Over millions of years, the star's immense pressure and heat maintain a delicate balance. Nuclear fusion in the core generates energy that pushes outward, countering the gravitational pull of the star's own mass. But once the fuel is exhausted, that outward pressure collapses. Gravity gains the upper hand. The star's core shrinks, compressing matter into smaller and smaller volumes. What begins as a gentle contraction accelerates into catastrophe. In the final seconds, the core collapses at a velocity that defies human imagination. The resulting implosion ignites a supernova. An explosion so bright it can outshine entire galaxies. Yet while the outer layers of the star are hurled into space, the core continues collapsing past the limits of atomic structure. Electrons are crushed into protons. Protons themselves are squeezed. Particles fuse into exotic states, then collapse further still. The gravitational pressure becomes unstoppable, and the core collapses into a singularity, a point of infinite curvature, shielded from the rest of the universe by the event horizon. The event horizon marks the threshold of no return. It is not a physical surface but a boundary, an invisible perimeter where the escape velocity exceeds the speed of light. Beyond this boundary, all trajectories, all futures, all possible paths lead inward. Even light, the fastest entity in the universe, cannot escape. The horizon is a one-way membrane, separating the observable universe from a region where time and space fall toward the singularity. Like water rushing down a gravitational waterfall, surrounding the event horizon, the environment is anything but silent. Gas clouds, stellar debris, and drifting matter gather into a spiraling structure known as an accretion disk. This disk becomes an arena of violence. Friction compresses matter into temperatures of millions of degrees. Particles collide at relativistic speeds, producing bursts of radiation that can be detected across galaxies. Magnetic fields twist into colossal structures, launching jets of high-energy particles thousands of light-years into space. These jets can pierce the surrounding darkness like cosmic lighthouses, signaling the presence of a hidden titan. Despite the chaos around it, the black hole itself remains serene. No sound or light escapes its boundary. No message, no matter, no hint of its interior leaks into the cosmos. From the exterior, it appears as a perfect sphere of darkness set against the luminous maelstrom of the accretion disk. Its silhouette, shaped by gravitational lensing, becomes a ring of warped spacetime. The surrounding light curves into a halo, creating the eerie image of a glowing eye staring through the infinite void. As matter approaches the event horizon, time dilates. According to the principles of general relativity, gravity affects not only space but also the passage of time. In the vicinity of a black hole, time moves slower relative to regions with weaker gravitational fields. From an external perspective, an object nearing the event horizon appears to slow, dim, and freeze, fading into darkness. From its own perspective, time passes normally, while the universe beyond accelerates. A few moments near the horizon could correspond to centuries or millennia. Elsewhere, deeper within the black hole, the nature of space becomes increasingly distorted. The familiar geometry of three-dimensional space begins to warp. Directions lose their traditional meaning. Radial distance collapses, while the inward pull strengthens. Tidal forces stretch matter vertically and compress it horizontally. The difference in gravitational pull between two nearby points can grow enormous. In smaller black holes, these forces become strong enough to tear apart any structure long before the event horizon is crossed. In supermassive black holes, the event horizon is so large that the gravitational gradient is gentle, allowing the interior to be crossed without immediate destruction. Beyond the horizon, all paths lead inward, not because of motion but because spacetime itself curves that way. The concept of falling becomes misleading. Spacetime, like a flowing river, drags all objects toward the singularity. Resistance becomes impossible. No engine, no force, no physical intervention can counteract this inward progression. The presence of the singularity warps the internal geometry so drastically that traditional descriptions of distance, duration, and orientation cease to hold meaning. Approaching the singularity, the laws of physics become increasingly incompatible. The equations of general relativity predict infinite curvature, while quantum mechanics forbids such infinities. The result is a paradox. The universe cannot describe what occurs at the singularity because the frameworks designed to interpret reality fail. This region marks the border between known physics and an uncharted realm where a unified theory, combining quantum mechanics with gravity, must one day be found. Some theories propose that the singularity does not truly exist as a point, but as a region of finite size defined by quantum effects. Others suggest that the interior of a black hole might connect to distant regions of spacetime through wormholes, a theoretical bridge linking separate universes or distant points within the same one. Yet another interpretation proposes that black holes may act as seeds from which new universes emerge, each singularity giving birth to a new Big Bang, with its own physical laws and dimensions. These ideas remain speculative. No observation has yet penetrated a black hole's veil. The event horizon remains the ultimate boundary of knowledge. Within it lies a domain the universe protects fiercely from inquiry. Black holes themselves are not eternal. Through a process known as Hawking radiation, quantum fluctuations near the event horizon allow particles to escape, gradually reducing the black hole's mass. The evaporation is extraordinarily slow for large black holes, occurring over durations far beyond the current age of the universe. Yet at the end of their lifespan, even the most massive black holes will evaporate completely, releasing a final outburst of energy before disappearing. In the distant future, when the last stars have died, when galaxies have dissolved, when the cosmos has stretched into near emptiness, black holes will remain as the final objects of significance. They will outlive every star, every planet, every fragment of matter. Only after unimaginable epochs will they vanish, leaving behind a universe silent, cold, and nearly empty. Black holes are paradoxes, destroyers that shape galaxies, voids that influence cosmic evolution, regions of absolute darkness surrounded by radiant chaos. They are among the most powerful engines in existence, yet they reveal nothing of themselves. They embody both the limits of physical law and the promise of deeper understanding. They stand as monuments to the universe's most extreme possibilities. At the intersection of gravity, time, and the geometry of space, black holes form the frontier of human knowledge. They remind that while the universe can be charted and measured, it remains vast enough to harbor mysteries that challenge comprehension. In their depths lie questions that redefine the nature of existence itself.